Find the area. Use 3 and 14/100 as the value of pi. So we have this irregular figure going on here, and it consists of some rectangles and a semicircle. What's cool is that the semicircle already has a dotted line drawn here, and we know that its diameter is 2.5 feet. So if its diameter is 2.5 feet, then its radius is going to be 1.25 feet. So we're going to use that when we're calculating the area of the semicircle. And now let's actually split this into 3 rectangles. So we have a top rectangle, a vertical rectangle over here to the right, and then a bottom rectangle. Since we know that this is 2.5 feet, and we know this is 2.5 feet, together that makes 5. So this remaining part is going to be 3 3/4, or 3 7/5 for this part. And I'll label it on this side. 3 3/4 feet. All right, so now we can find the area of each of these rectangles and the semicircle. So let's do the area of the semicircle first. It's going to be half times pi, which we're using 3 and 14/100 as its value. And its radius is 1.25 squared. So the area of the semicircle is going to be that's going to be 2, and these all go to 3 decimal places. So let's do 453 thousandths. Okay, and now let's find the area of this top rectangle. And that's going to be 4 feet by 2.5 feet. So if we have 4 times 2.5, that will be 10 square feet for that one. And now let's do the middle. The area of this right side, I'll do that, area of the right side rectangle, that's going to be 3 3/4, or 3 7/5 times 1.5. And when we multiply those together, we're going to get 5 5/8, or 5 625 thousandths square feet for that one. So this is done, this is done, and this is done. Now we have this bottom rectangle. So the area of the bottom is going to be, the length is 7 7/5 times 2.5. That's 19.375, or 375 thousandths square feet. And now if we add up all of these values, we will get the total area. So let's do that. So we have and we get 37 and 453 thousandths. So the total area is this when we add up all of those values together. And yep, we got all the solutions that they found.